Hi, this video is about one of the most shocking discoveries in all of physics. Now in physics we try to make sense of the world and try to understand how things behave. So let's start with tape today. I've got two pieces of tape right here and they are clear pieces of tape, so it might be a little hard to see this, but if I bring these two pieces of tape close together, nothing happens, right? That's to be expected. They're just regular old pieces of tape. But if I were to take these pieces of tape and lay them down on this whiteboard, put one right there and put another one on top of it, like so. And then I were to take these pieces of tape back off the whiteboard and then pull them apart. I want you to observe what happens when I bring them back together again. So I'm going to try to pull them apart. Hopefully they're not going to stick to me. I'm just going to try to be very careful about it. Pull them apart. This one's stuck to me. That's all right. I can still bring them close together. Watch what happens now as I bring them together. Did you see that? So it jumps over. And I wish I could get the other one to jump too, but it's stuck to me. But when you bring these two opposite pieces of tape together, they are attracted to each other. And this is quite a discovery. I'm going to try to keep my top piece here like this. So a top and a bottom piece of tape, when they're pulled apart, they will attract each other for some reason. Now, what if I were to do the same experiment, but instead of doing a top piece and a bottom piece and bringing them together, what if I got one of my top pieces and I got another top piece from over here? So I've already got two pieces of tape on top of each other here. If I pull this one off and bring this over next to my other top piece, observe what happens here. Do you see that? These are two top pieces and they will have nothing to do with each other. They're repelling each other until I turn it around a little bit, then it falls in, but you can clearly see they're pushing apart. And so top pieces, when they're brought next to other top pieces of tape, they repel each other. And we could try this as well with two bottom pieces, and they also happen to repel. So there's something funny going on with these different pieces of tape. Each piece of tape acquires an unseen quality that either attracts opposite pieces or repels the same kinds of pieces. So something unseen is happening here. What's going on? The same kind of effect can be seen when you take like a balloon and you rub it up against your hair. And then you stick this balloon, you can attract it to the wall and it sticks. Or you could take like a random piece of paper here and you can attract a piece of paper with it. So we have another similar kind of thing happening here. Like this isn't a magnet, so what's going on? It's just a balloon, but it can somehow draw objects to it. Well, this kind of phenomenon has actually been known about for thousands of years. This unseen quality has been observed and known since 600 BC when the Greek mathematician Thales, here he is, discovered that amber from like a tree can be used to attract other objects when it's rubbed with fur. So just like you rub a balloon against your hair, if you rub tree amber against some fur, then it can also attract other objects. So this has been known for a long time. And this is significant. I bring this up because the Greek word for amber is this. And if you're not fluent in Greek, this says electron. And this is where we get the name electricity from. So what we're looking at is something we know as today as electricity. So this amber-like or electric property has been experimented with for, as you have now seen, thousands of years. People have tried to experiment with objects that have this amber-like or electric property. And so that's the study of electricity, in essence. And we get all the way to Benjamin Franklin, and he proposed naming these two different electric qualities that either attract or repel, like the top and the bottom pieces of tape. He proposed naming them positive and negative charges. So if you have like two top pieces of tape, we're going to call those two positive. And then if you have opposites, we have a positive and a negative. So if you have the same charge, positive and positive, negative, negative, they repel, and opposites attract. So the next question would be, well, what kinds of objects have this kind of behavior, this electric behavior? We've seen it in tape, we've seen it in balloons, we've heard it's in amber. Where's the line? What's the limit? Like, what kinds of objects have this electric property? Well, to answer that, we come to another fact that we know from even more recently, and that is that today we know all of these electric charges ultimately come from subatomic particles inside of atoms. So, these atoms are made up of protons and neutrons and electrons, and electric charges are present within protons and electrons. And protons have a positive charge, electrons have a negative charge. And because all matter is made up of these atoms, then that means literally all matter, everything, has electric capabilities, because everything's made up of positive and negative charges. But most of the time, atoms and objects have equal numbers of positive and negative charges, so that makes them electrically neutral. Neutral means that if you add up all of the overall charges, the net charge would be 0. So that's all I've got for you in this video. Remember, shortcuts make long delays.